Hey there, Seahawks, it's Miss Adams, and in this video we're going to go over the multiplication rule for independent events. Alright, so two events are independent if the outcomes of one does not affect the outcome of another. Otherwise, events are called dependent. If A and B are independent events, then the probability of A and B is equal to the probability of A times the probability of B. So if I know the events are independent, I can just multiply their probabilities together. All right, so our first example. Suppose that the probability that a baby in a particular family will have brown eyes is 1/3. Suppose further that the probability that a baby in the same family will have brown hair is 3/4. Assume eye and hair color are independent events. Find the probability that a baby will have brown eyes and brown hair. Okay, so they already said assume that they were independent. So since they're independent, the probability of A and B is equal to the probability of A times the probability of B. So the probability of brown eyes and brown hair is equal to the probability of brown eyes times the probability of brown hair. So it'd be 1/3 times 3/4. Okay, multiplying fractions, no big problem. Top times top over bottom times bottom. That gives me 3/12, which I could simplify to 1/4. All right, or 25%. Find the probability that a baby will have brown eyes and not brown hair. So the probability of brown eyes and the complement of brown hair, which is not brown hair, would be 1/3 times, well, if brown hair is 3/4, then not brown is 1/4. So that's going to multiply to 1/12. Part C, it says find the probability that a baby will have neither brown eyes nor brown hair. All right, this one is a little bit more complicated. So this is the probability of brown eyes or brown hair, but the complement. So not brown eyes or brown hair. They'll have neither nor. All right, so this is 1 minus the probability that they do have brown eyes or they have brown hair. Okay, which is 1 minus the probability of brown eyes plus brown hair minus the probability of both. Okay, so remember for or, that's going back to the addition rule. So it's the first option plus the second option minus the overlap that they have. All right, so the probability of brown eyes is 1/3. Probability of brown hair is 3/4. And in part A, we found the probability of brown eyes and brown hair and to be 1/4. Okay, so if I add those and I subtract 1/4 and then I subtract that from one whole, I get 1 minus 0.833, and you can keep it in fraction form if you want. I just decided it'd be easier to switch to decimals at this point, which gives me about 0.1667, or about 17%. All right, example 2. If you flip a fair coin 10 times, what is the probability of getting at least one head? All right, so the probability of at least one head in 10 flips, okay, at least one is, basically this is saying the probability that not all tails, I'm not getting all tails in my 10 flips, because at least one of them is going to be a heads. So this is 1 minus the probability of getting none, all right? So anytime they ask for at least one, it's 1 minus the probability of none. Well, if none of them were heads, it would mean I got 10 tails in a row. So I'm going to do 1 minus the probability of getting 10 tails in a row. Okay, so getting 10 tails in a row, well, when I flip a coin, if it's a fair coin, I have 50-50 chance of getting heads or tails. So this would be 1/2 times 1/2 times 1/2 times 1/2, 10 times. So it's 1 minus that. Instead of doing that, I could just do 1/2, which is 0.5 to the 10th power. Okay, and if you're using your phone, most of you have to turn your phone sideways and then look for the X to the Y or the Y to the X button on your calculator. So when I do that, I end up with 0.99902. All right, so there's a 99.9% chance if I flip 10 coins, if I flip a coin 10 times, that I'll get at least one of them to be a heads. It's very unlikely to get 10 tails in a row. All right, example 3. If LeBron James has a free throw percentage at 75%, what are the odds of him making 8 free throws in a row? All right, so free throw number 1. If he has a 75% chance, that's what it looks like, right? Then free throw number 2, the next one, he's gonna make 75% of the free throws he made before. So 75% of 75%. And then free throw number 3 is 75% of 75% of 75%. Okay, you might remember back from algebra that of really means to multiply. So I have 75% times 75% times 75%. Okay, so if each throw is independent, like the first shot is independent of the second shot, okay, which is independent of the 10th shot, then what I'm doing is 0.75 times 0.75 8 times, or 0.75 to the 8th power, which works out to be 0.1001. Okay, so there's a 10% chance that he would make 8 free throws in a row if he really is a 75% free throw shooter. All right, example 4. Surgeries involving implants sometimes result in the patient's body rejecting the implant. A certain surgery has a rejection rate of 11%. The rest of the patients successfully accept the implant. Assuming that the results from each patient are independent, in a random sample of 8 of these surgeries, find the probability that at least one patient rejects the implant. So remember, at least one would be 1 minus the probability of none. So 1 minus they all accept it, or none of them reject it. So at least one rejects out of 8. So this is 1 minus the probability that none of the patients out of 8 reject it, or 1 minus all 8 accept it. Okay? So the probability that they reject it is 11%. So the probability they accept it is 0.89. And since it's 8 patients, this is going to be to the 8th power. So it's going to be 1 minus 0.89 to the 8th, which is 0.606. So there's a 60.6% chance that at least one patient out of 8 will reject the implant. All right, so again, the rule is for at least one. If I want to find the probability of at least one success, it's 1 minus the probability that they're all failures. If I want to find the probability of at least one failure, it's 1 minus the probability of all of them being successes. So it's always, for at least one, it's 1 minus the probability of none. All right, go Seahawks.